Good afternoon, folks. We're going to get started our second installment of our simulation webinars. Again, this is going to be a general session on CFD specific. As the title says, Design and Optimize with Autodesk CFD 2018. My name is Robert, Industry Account Executive. We take care of your accounts for Autodesk software. Some of you may have dealt with me in the past. That's great. If not, give me a shout anytime. We can talk about simulation topics. Dan Montano is our application specialist. He's a simulation specialist, inventor specialist, vault specialist, you name it. We have a lot of titles under him, mostly all Autodesk, and a couple other titles as well. But today we're going to focus specifically around the CFD and how that can impact your business. Hello. So if you also are a social media type person, you can follow us on all the media links pretty much. As well, we do have company profiles on LinkedIn, as well as personal profiles. We're all linked to that too. Next slide, please, Dan. Thank you. So, a little story about SolidCAD very quickly. We began many moons ago. We started off as a Autodesk partner back in the day, and slowly grew to Canada's first platinum partner a number of years ago. We're part of a larger group. I'll speak about that shortly. As well, we have the largest tech team, and Dan being one of them, in Ontario. And this is what I was talking about before. So we are part of the Cancel family. As of August 1st, 2015, a couple of years ago, we joined the Cancel family across Canada. We are Cancel's business here in Ontario, SolidCAD that is, and we've grown to a larger group of all in sales, as well as a much larger group of tech people across all of Canada, east to west, in different time zones. We are a official training facility for Autodesk products. So if you have a need for some sort of training, whether it's custom or standardized, first off, if it's something standard, why not visit our website and check our events calendar. You will see that it will be posted whenever we have events for whether it's training or even webinars like this. It'll be posted there. But if you need something a little bit more customized, reach out to us and we will tailor something for you specific. A little quick story about how we have evolved as well with Autodesk products. We do partner with many other product companies, whether it's hardware or software, for various things. I think people probably know what Bluebeam is. If not, PDF manipulation, PDF viewer, a great tool for that. Talk to us about that if you wish to know a little bit more. And you know, how do we do things here at SolidCAD? We really are a focused company on customer needs specifically, where it will make more business objectives come to light, where we do some assessments or we do a discovery with you. We want to make sure that if it's a training or whatever we're doing with you, we understand your business well and your business issues. And we tailor our solutions, software, training, mentoring, all that around your absolute specific needs. And don't forget, those that have a maintenance or a subscription to an Autodesk product through us, please reach out to us when you have an issue, have a technical issue with the software. Just dial our number, extension 2. talk to any one of our team members. We do have 2 that man the phones 9 to 5, 5 days a week. And if there's something special, they'll pass it off to someone like, for instance, Dan. If it's a CFD specific question, Dan will be helping you out, whether it's by phone direct, email, or he'll just show up at the door. Thank you. All right, and as I said, our consulting services, we tailor specific to your business needs. All right, I'm going to hand it over to Dan, and Dan can, basically start to talk a little bit about CFD. I just do want to mention, as I said, these are general sessions right now. We'll have another one coming up in the next quarter around Nastran InCAD, I believe, right, Dan?
That's
and as well after that, we'll start to focus in on the different products and specific tasks. So sit back and enjoy the ride. Thank you very much. Dan, have fun.
Thank you, Robert. Thank you, everyone, for joining us today, this afternoon. I hope you'll find some interesting discussions here, topics of discussions that hopefully will raise some questions on your side, and maybe start to think of using some of these techniques and tools in your day-to-day design process. So what I'm showing here is the current Autodesk simulation portfolio. So a range of products from structural mechanics to structural architecture to flow and thermal analysis, simulation of injection molding processes, and advanced analysis of composite materials. Autodesk has invested a large amount in a number of acquisitions in the last 10, 12 years in the simulation space. And a consequence of these acquisitions are a number of products which tend to work in conjunction with each other by moving data back and forth. So why do we even think of simulating? Well, the reality is these digital simulations provide information that is difficult or impossible to obtain through physical testing alone. So the digital simulations are not a replacement for physical testing. They will augment your understanding of the product behavior and the process, and hopefully they will allow you to be better informed and make design decisions and take a clearer path through your product development. The idea here is to simulate early and often, because this way you can go through multiple design solutions that you can rapidly test, and you can again make an informed decision on the evolution of your design towards an optimum. The reason for this is product failure has far-reaching implications in an organization, far beyond engineering department. So we want to basically use any techniques we have at our disposal early in the process to ensure a product that performs properly. So traditionally, the simulation process was done towards the end, after the product has failed, and that's less than ideal. We would like to follow this newer design paradigm where the simulation tools and the simulation techniques are employed early in the design process by design engineers. So the design and engineering time frame right after conceptualization would be the better timing to use the simulation tools, because at that point we can influence the functional capabilities of the product on a higher extent with a lower cost of change. So in terms of Autodesk CFD, what would differentiate Autodesk CFD from other CFD solutions? And we have a number of pointers here that I'd like to go through. First of all, the CAD-driven design study environment. This will allow us to push your CAD model into the CFD package, make changes again on the CAD side, and push it again on the CFD package, and update the boundary conditions, as well as compare side by side the various results. The model preparation could be done with a tool called SimStudio Tools, which is now included with CFD installation. It's a very powerful CAD manipulation and defeaturing or simplification tool for preparing your CAD model. It's somewhat similar to Fusion or Fusion 360 in terms of its interface. Quite an easy to use tool. On the mesh size, the mesh creation size, we have some unique features there in terms of auto sizing and mesh adaptation, which will increase mesh density and areas of interest, for example, areas of high thermal stress, once transferred to simulation mechanical or Nastran in CAD, and that will allow us to get accurate results with minimal effort. The ability to run multiple analyses in the cloud through cloud computing is also a great advantage of Autodesk CFD. I'm going to come back to this topic later on. Basically, you are taking advantage of nearly infinite computing power as opposed to your local workstation. Another important aspect here is Autodesk CFD is CAD system neutral. So what I mean by this is it actually integrates with other CAD packages like SolidWorks and Creo on top of the Autodesk Inventor. So where can we help in terms of getting your designs to perform better? Here are some areas of expertise: electronics cooling, data centers, LED lighting, machinery and valves, and AC industries. Let's take a look at some in a bit more detail. So in terms of electronics cooling, Autodesk CFD will be used to improve enclosure design for a better thermal management, cooling fan optimization, visualize the airflow inside and over electronics components to find out dead areas and recirculation areas where the temperatures could increase. And PCB board configuration. There are a number of specific material models that we employ in Autodesk CFD for for a better definition of the finite element model. In terms of data center, there is a global trend to reduce energy consumption and assess different arrangements of hot and cold aisles, different placements of floor and ceiling tiles, evaluation of free or fresh air cooling, the number of computer room air conditioning units, and so on. So these optimization processes are considered for new developments, but also for retrofitting existing data centers. Simulation CFD is ideally suited to assess the impact of all these energy change measures. In terms of LED lighting, we're concerned with heat dissipation, improved efficiency, design simplification, environment loading. All these areas could be tackled with Autodesk CFD. Valves and machinery, heat exchangers, pumps and compressors have their own unique problems like erosion, cavitation, thermal effects. We can again use Autodesk CFD to understand behavior of flow of fluid inside the component, which is most of the times impossible to do through physical testing. On the AC side, we are concerned with thermal comfort of users of that space, smoke and contaminants migration, internal and external flow, natural ventilation as opposed to air conditioning. Let's look at some of the CFD features now. So design study environment is the pre and post processor of your CFD tool. We'll take some points on that. We'll look at some of the fluid flow and heat transfer options, as well as fluid motion, and we'll talk a little bit about geometry and meshing. So the design study environment is an intuitive user interface that will let you set up these fluid flow and thermal studies. There are some unique tools there that will help you automate the creation of these analysis, the use of templates, the automatic application of materials in boundary conditions based on component names. These tools are very useful on the pre-processing. We can compare critical values, review results across multiple designs in your decision center, which is a post-processor side of design study environment. We can do these comparisons from both quantitative and qualitative aspect to facilitate a better, a more informed design decision. It'll allow you to customize your materials and will allow you to have an interoperability with other Autodesk products like SimStudio that I mentioned earlier, NASA and InCAD for structural stress, simulation, mold flow inside for conformal cooling, Showcase or Vault on data management side. Some of the capabilities of Autodesk CFD are available in the basic package, like different laminar and turbulent modes, incompressible and steady state analysis, conduction, convection, forced and natural heat transfer modes. Others are available in the middle package called Autodesk CFD Advanced. For example, compressible flows, transient or time-dependent analysis, mixing, radiation as a heat transfer mode, solar loading, humidity, current and voltage, cavitation. So the ability of choosing the right level of the tool is going to be important. You can also, if you deal with motion flow, you can also look at CFD motion, which will help you understand better how, let's say, pumps, valves, piston, other mechanical devices interact with and respond to fluid flow. So the motion can be fluid driven, so components are reacting to flow, or they could be mechanical driven, so components drive the flow. We can look at different motion types: angular, unconstrained, combined orbital and angular, combined linear and angular, sliding vane notation, linear, rotating or turbo machinery. On the geometry and meshing side, we have opportunities there for importing external files in, let's say, IDF format, like 3D CAD models of electronics components on the CFD for electronics application, the ability of creating internal and external fluid volumes, and the ability to use SimStudio as a simplification tool, as a defeaturing tool to prepare a more optimal finite element model for your CFD analysis. Let's look at a few case studies now on the consumer electronics side, factory ventilation, and data centers. So on consumer electronics side, here's a modem design study where we have an example here of optimization of the airflow and heat management inside a modem unit. The original baseline design on the left side had a small housing and a large heat sink, and it was found that a critical component had a temperature at 62.8 degrees Celsius overheating. New concept design was featuring a larger housing, a larger extruded heat sink, and force flow with a fan on one side, in a bid to divert more airflow over the critical device. This was useful in reducing the temperature to 51.2 degrees Celsius, but still this was considered too high for that critical component. So through simulation CFD, Autodesk simulation CFD, it became clear that the optimum mode of heat removal was through conduction. And here's an optimized design with a larger copper content on the PCB board, heat sink removed, a fan in the center, and this way the temperature was reduced to just 44 degrees Celsius, 30% less than the baseline design, with a lighter and more cost-effective solution. Another point here is the removal of the heatsink provided less flow resistance inside the enclosure. This way the fan could operate at a higher point on the fan curve from 0.6 CFM to versus 0.44 CFM. So you can see how CFD, Autodesk CFD helped understanding better the behavior of that component and coming up with a better solution than the baseline. Here's an example of the interface. This is the Autodesk 3D printer, Ember, which is has its plans available open source for you to download. And what you can see here is a trace animation of flow lines on the second design that include fans. First scenario there includes a fan running at 4,300 RPM. Here's a design change through SimStudio tools, a direct modeler, quite easy to make model changes there. The outlet has been increased by 40 millimeters on each side. The model has been re-imported and the analysis have been rerun. And here's the decision center, which will let you compare side by side the two different CAD models, each of them with two different fan speeds, 4,300 RPM and 2,500 RPM respectively. Different plots of ISO surfaces, of arrows for direction of flow could be visible. And on the decision center, again, we have a list of summary values, and we can easily plot different output measures, temperature, velocity in different directions, and so on. So the interface is very clean, very user-friendly, if you want, to help you come up with at least a qualitative solution quickly. Factory simulation. So this is a HVAC or ventilation example. Large OEM manufacturer has a corporate initiative to reduce ventilation costs by 25% over 3 years. And the first step here was to assess the inefficiencies of the plant due to variation in energy consumed month to month. And secondly, the reduction in accuracy on certain CNC machines and even some failures of those, and waste products due to ambient changes in temperature due to thermal expansion. So they need to simulate performance of existing ventilation system first to identify these inefficiencies, then to assess the effects locally on individual operating stations, and then find out what's the best ventilation strategy to extract pollutants such as well smoke. Here's a plot from 3D result model. You can see the ducts there and colder air coming down from them. Let's look at some other sample results that show the temperature variation on a plane at operator height. You can see high pressure, low temperature regions. The bottom right showing possible overcooling, over conditioning, high velocity flows, as well as the under conditioning or undercooling, lower pressure and high temperature areas, top left, top right. So this analysis will let you understand how the temperature varies in different different seasons there, even summer versus winter. Remember, solar loading is also an option on the CFD Advanced, so you can find out exactly how much energy that model absorbs from the sun at different times a day and year. You can see here results are very different. Winter time, heat loss through the roof, having a significant impact on the air temperature inside the factory. On the data center side, this is an example from a data center operator in the United Kingdom. They looked at two different ventilation strategies based on seasonal weather conditions. The first image shows cool air being drawn from the outside to maintain a constant internal temperature. The second image shows recirculation of the warm air within the data center, small amounts of cold air being drawn in to maintain the temperature uniformity. And different insights on the section of the data center that you can get using Autodesk CFD. The typical workflow shown here in an example from a hospital records department, basically a large server room. Typical workflow starts with getting the model from the architect or an MEP client, running a baseline simulation that shows the temperature throughout the room. Again, you can compare that with some local measurements that you may have, sensors at different locations. So that's the result of that baseline analysis. You can see there the complexity of the model: 43 server racks, 6 UPS units, no plenum on the ceiling, irregular layout with a different obstructions, so additional 72 kilowatts of equipment required there. But once the analysis on a modified simulation model has been run, it has been determined that by widening the cold aisle, closing off some of the ceiling tiles across one side of the room, and moving a couple of computer room air conditioning units or crack units, they were able to achieve adequate cooling whilst deactivating one of the crack units. So that allows for lower maximum temperatures and up to 25% reduction in running costs. Okay, so this allows you to evaluate the impact of all these decisions, all these energy conservation measures or ACMs that you might want to take on the server room or data center before moving any equipment, before spending any money on relocating and redesigning the room. As you can imagine, these are large analyses which are seldomly easily run on a workstation level computers. So if you have the ability of or the access to an HPC high performance computing cluster, then that's good. But otherwise, you are probably better off using the cloud. So what I mean by this is Autodesk CFD allows you to run these analyses locally on the computer at your location, a workstation or HPC cluster, or in the cloud. So by sending the analysis in the cloud, the advantage would be that you can run multiple analyses in parallel and not lock up a computer for many hours. That will allow you to run these analyses sequentially. So there's clearly an advantage on looking at multiple design scenarios very quickly through the cloud. So design study environment is the user interface, the pre and post processor, as I mentioned, and that will be complemented with your server level, basic, Autodesk CFD, advanced, the middle level, or CFD Motion, the highest level. So these two components of your installation are required. And to this, you can add cloud service entitlements on one or more users and purchase cloud credits to run the analysis in the cloud, taking advantage of a lot more computing power. That's it. Thank you very much. If you have any questions, our email addresses are on screen. You can also use events at solidcad.ca. And I hope you found this useful and generated some interest and questions on your end. Thank you very much. Hope to see you soon.